Hello everyone and welcome to the lecture on Amazon API Gateway. So this lecture will contain all these topics. What is Amazon API Gateway? Features of API Gateway. Building REST APIs with Amazon API Gateway. Creating HTTP APIs with Amazon API Gateway. Building WebSocket APIs with Amazon API Gateway. Choosing between REST APIs and HTTP APIs. And Amazon API Gateway concepts. So what is Amazon API Gateway? Amazon API Gateway is a fully managed service that simplifies the process of creating, publishing, maintaining, monitoring, and securing APIs at any scale, which allows developers to focus on building their applications. With API Gateway, you can create both RESTful APIs, WebSocket APIs, and HTTP APIs, providing you flexibility in designing and implementing your application's API architecture. By supporting WebSocket APIs, API Gateway enables the development of applications that require real-time bi-directional communication between the client and the server. API Gateway seamlessly integrates with various backend services, including containerized workloads, serverless architectures, and traditional web applications, making it adaptable to different application requirements. API Gateway takes care of essential tasks such as managing API traffic, supporting cross-origin resource sharing, CORS, handling authorization and access control, throttling requests, and monitoring API performance and usage. API Gateway offers a tiered pricing model, which allows you to reduce cost as your API usage grows. You only pay for the API calls you receive and the amount of data transfer out, making it cost-effective for applications with varying usage patterns. Features of API Gateway. 1. Its support for stateful, which is WebSocket, and stateless, which are HTTP and REST APIs. Powerful, flexible authentication mechanisms such as AWS Identity and Access Management Policies, Lambda authorizer functions, and Amazon Cognito user pools. Canary release deployments for safely rolling out changes. CloudTrail logging and monitoring of API usage and API changes. CloudWatch access logging and execution logging, including the ability to set alarms, ability to use AWS CloudFormation templates to enable API creation, support for custom domain names, integration with AWS Web Application Firewall (WAF) for protecting your APIs against common web exploits, and one more is integration with AWS X-Ray for understanding and triaging any performance latencies. Okay, building REST APIs with Amazon API Gateway. API Gateway REST APIs consist of resources, which are logical entities accessed via resource paths, and then you have methods which correspond to REST API requests and responses. Examples includes, for example, let's say you have /student/incomes, which are resource paths. So in this case, I'm giving the example of, let's say, /incomes resource path, and you have HTTP methods like get, post, put, patch, delete, and combining a resource path and a method. An HTTP method identifies an API method. For example, you can have post incomes, get incomes, put incomes, patch, and delete. So these are all the possible combinations. So you have post/incomes to add income, and you have something like, let's say, get/expenses to query for expenses. In API Gateway REST APIs, in API Gateway REST APIs, the front end is encapsulated by method request and method responses, abstracting the backend implementation details from the app. The API interfaces with the backend using integration request and integration responses, allowing seamless communication between the front end and backend. So basically, you have front end, which will be let's say your user interface. Then you have, let's say, form and all. Then you put let's say you query, you click some button and you have query, so you will call get, and you want to create something, you say post, and you want to update something, you put method. So that's how you integrate your front end, which are encapsulated with request and responses, and that in turn invokes the backend, which is your API gateway, to handle the to basically route the request to either Lambda function or your EC2 application. Okay, So with let's say with DynamoDB as the backend, the API developer sets up the integration request to forward the incoming method request to DynamoDB, specifying the required action, IAM role, policies, and input data transfer. DynamoDB returns the result as an integration response. So this is one example. So end to end. So you have user interface, you have API gateway, and finally backend is DynamoDB. So user interface, you click some button, API gateway will come into picture, and then you have it will forward to DynamoDB. Then it will process and send back to your user interface. To route the integration response to the appropriate method response, you can configure the integration response to map required response parameters from integration to method and translate the output data format if needed. API gateway allows defining a schema or model for the payload to facilitate body mapping templates setup. So basically how to map your whole put, get, post to DynamoDB table, let's say, and you can just map the parameters. So which either it should create an entry in the DynamoDB table, it should update, or it should get. So you can just map this one-to-one mapping between all the way from your user form to the backend database, in this case DynamoDB, let's say. API gateway provides additional REST API management functionalities such as generating SDKs, which are software development kits. So SDKs, so you can use it for your programming language of choice, let's say Java, Node.js, Python, and creating API documentation using OpenAPI extensions, and throttling HTTP request to manage API usage. So we throttle just to avoid any kind of distributed denial DDoS attack. So you can throttle it. So somebody is trying to like overwhelm your system, so you can throttle those HTTP requests also. So now next is creating HTTP APIs with Amazon API Gateway. HTTP APIs enable the creation of RESTful APIs that offer lower latency and lower cost compared to REST APIs. So these are slightly different but less limited, but a different way. So with HTTP APIs, you can send requests to AWS Lambda functions or any publicly routable HTTP endpoint, providing flexibility in backend integrations. A common use case is creating an HTTP API that integrates with the Lambda function on the backend. When a client calls the API, API gateway sends the request to the Lambda function and returns the function's response to the client, and this facilitates some seamless communication between the client and the backend. HTTP APIs come with built-in support for OpenID Connect and OAuth 2.0 authorization, which further enhances the security of your APIs by enabling authentication and authorization mechanisms. HTTP APIs have built-in support for cross-origin resource sharing (CORS), making it easier to handle cross-origin requests and ensure proper access control for your APIs. HTTP APIs offer automatic deployment capabilities, simplifying the process of deploying and updating your APIs without manual intervention. Okay, next one is building WebSocket API. So we have three, right? REST, WebSocket, and HTTP API. So in WebSocket API, both the client and server can send messages to each other at any time, enabling backend servers to easily push data to the connected users and devices without complex polling mechanisms. So this is bidirectional. So you think of a tunnel which is being set up, and client and server is exchanging data. You can build a serverless application using an API gateway, WebSocket API, and AWS Lambda to send and receive messages to and from individual users or groups of users in a chat room. You can invoke backend services such as AWS Lambda, Amazon Kinesis, or an HTTP endpoint based on the content of the messages received through the WebSocket API. API Gateway WebSocket APIs allows you to build secure, real-time communication applications without the need to provision or manage any servers to handle connections or large-scale data exchanges. Targeted use cases for WebSocket APIs include real-time applications such as chat applications, real-time dashboards, for example stock tickers, and real-time alerts and notifications. API Gateway provides WebSocket API management functionality such as monitoring and throttling of connections and messages using AWS X-Ray to trace messages as they travel through the APIs to backend services and easy integration with HTTP, HTTPS endpoints. Okay, now choosing between REST APIs and HTTP APIs. So because both are very similar, so let's see what are the how to choose. So REST APIs and HTTP APIs are both RESTful API products. A REST API support more features than HTTP APIs, while HTTP APIs are designed with minimal features so that they can be offered at a lower price. Choose REST APIs if you need features such as API keys, per client throttling, request validation, AWS WAF integration, or private endpoints. So if you need these features, go with REST APIs. Choose HTTP APIs if you don't need those features included with REST APIs. So price is lower and features are less. Okay, now let's cover all the API gateway concepts. So first one is API endpoint, a host name for an API in API gateway that is deployed to a specific region. The host name is of the form, so there is API ID, then .execute API /.region. So region will be part of API, so it will be US East 1, US West 1, US West 2 .amazonaws.com. So in the endpoint you will see the region being mentioned. The following types of API endpoints are supported. You have edge optimized API endpoint, the default hostname of an API gateway API that is deployed to the specified region while using a CloudFront distribution to facilitate client access typically from across AWS regions. API requests are routed to the nearest CloudFront point of presence, which typically improves the connection time for the geographically diverse clients. So next API endpoint type is a private API endpoint, an API endpoint that is exposed through the interface VPC endpoints. So first one is for geographically diverse clients, next one is for VPC, and allows the client to securely access private API resources inside a VPC. So let's say you are in EC2 or some other like region or something, like in a single region, but if through VPC peering, but this is for virtual private cloud. And private APIs are isolated from the public internet and they can only be accessed using VPC endpoint for API gateway that have been granted access. So you have to grant access from which VPC endpoint you want to invoke this API endpoint. And lastly, we have third one is regional API endpoint, the host name of an API that is deployed to the specified region and is intended to serve clients such as EC2 instances in the same AWS region. API requests are targeted directly to the region specific API gateway API without going through any CloudFront distribution. And for in-region requests, a regional endpoint bypasses the unnecessary round trip to a CloudFront distribution. In addition, you can apply latency-based routing on regional endpoints to deploy an API to multiple regions using the same regional API endpoint configuration. Set the same custom domain name for each deployed API and configure the latency-based DNS records in Route 53 to route client request to the region that has the lowest latency. Okay, next important concept is API key, which is an alphanumeric string that API gateway uses to identify an app developer who uses your REST or WebSocket API. API gateway can generate API keys on your behalf, or you can import them from a CSV file. You can use API keys together with Lambda authorizers or usage plans to control access to your APIs. This is basically to make sure it's only authorized people can call. Let's say you have an application which call your APIs, so application will have that key. So otherwise anybody can call and overwhelm your system or create a distributed denial service attack. So this API key is basically guard against that kind of situations. Next important concept is API stage, which is a logical reference to a lifecycle state of your API. So you have something like dev, production, beta, v1, v2, and API stages are identified by API ID and stage name. So basically you would have seen like slash customer slash v1, v2 slash prod. So you just go from one stage to another. So dev, QA, prod. So this is whatever name you want to give. It's user friendly name. It's arbitrary. So you just provide a stage name, and in that when you invoke that API, the stage name will be there, so that you have version control and you move from one version to another, from one stage to another stage, and you can have different functionality based on the stage. Then we have callback URL. When a new client is connected to through a WebSocket connection, you can call an integration in an API gateway to store the client's callback URL. You can then use that callback URL to send messages to the client from the backend system. So this is only for WebSocket, so that there is a two-way communication. So when a client calls first time, you can call some kind of integration to store the client's callback URL. So client will give you the callback URL. So you process the message and the payload, and once everything is ready, you should know what is the callback URL to let the client know that something has been done. So you store it, and you have this callback URL to basically know how to contact back the original sender. Okay, next one is integration request. So the internal interface of a WebSocket API route or REST API method in API gateway, in which you map the body of a route request or the parameters and body of a method request to the formats required by the backend. So basically you integrate the sender with the backend. So this is the integration. If something comes up, which is the request, and you map how it should go with the final backend. So let's say DynamoDB. So request parameters body, how it should get mapped to the tables column, let's say. Then you have integration response, which is again how to send back, which is in the internal interface of a WebSocket API route or REST API method in an API gateway, in which you map the status codes, headers and payload that are received from the backend to the response format that is expected or returned to the client application. Then you have mapping template, a script in velocity template language VTL that transforms a request body from the front-end data format to the backend data format, or that transforms a response body from the backend data format to the front-end data format. Mapping templates can be specified in the integration request or in the integration response. They can reference data made available at runtime as context and stage variables. The mapping can be as simple as an identity transform that passes the headers or body through the integration as is from the client to the backend for a request, and same is true for a response, in which the payload is passed from the backend to the front-end client. Okay, next one is model. So a data schema specifying the data structure of a request or response payload. A model is required for generating a strongly typed SDK of an API. It is also used to validate payloads. A model is convenient for generating a sample mapping template to initiate creation of production mapping template. Although useful, a model is not required for creating a mapping template. So basically you can think of a model as a database model or some kind of schema. So if you have a model, you can generate the what we call as a strongly typed SDK, what we call as stubs or proxies, basically the template or the blueprint or the skeleton. So using that you can write code which is more like aligned or tightly integrated with your SDK of your choice. Then you have proxy integration, a simplified API gateway integration configuration. You can set up a proxy integration as an HTTP proxy integration or Lambda proxy integration. For an HTTP proxy integration, API gateway passes the entire request and response between the front end and an HTTP backend. For Lambda proxy integration, API gateway sends the entire request as input to the backend Lambda function. API gateway then transforms the Lambda function output to the front-end HTTP response. In REST APIs, proxy integration is most commonly used with a proxy resource, which is represented by a greedy path variable, for example something like proxy plus, combined with the catch-all any method. So this is something internal details. Okay, and last important concept is route, which is a WebSocket route in API gateway is used to direct incoming messages to a specific integration, such as an AWS Lambda function based on the content of the message. When you define your WebSocket API, you specify a route key and an integration backend. The route key is an attribute in the message body. When the route key is matched in an incoming message, the integration backend is invoked. A default route can also be set for non-matching route keys or to specify a proxy model that passes the message through as is to the backend components that perform the routing and process the request. And that's all. Thanks for watching.